Okay, suppose you are buying a flat, a HDB flat, and you wonder, right, roughly estimate wise, how big is the flat? So you enter there. Um, Maybe the owner tells you, oh, this is a squarish layout, very good. Approximately one side is about 10 meters. So you're thinking 10 meters, what's the area, right? So squarish, right? So we say 10 meters. Oh, that's 100 square meters. Then you think about it, roughly 1 square meter is 10 square feet, so that's 1,000 square feet. Wow, that's great. I like that. Okay, so that is basically how function call allows us to do. Now, functions themselves can be arbitrarily super complicated. Functions can call other functions. You can define functions within functions, and so on and so forth. We will discuss a lot more about functions later on because it deserves its own discussion space. Here, we want to make sure you understand that this is calling a function that represents a jump in the execution flow. We are pausing there, we are coming back, we are pausing there, execute the routine called calc square, then come back again. And we don't need to worry so much about where calc square is being located. All right, so even this will work. So 10 and nope, sorry, because we are calling the function before it is being defined. So we need to do that. But we can define it right before and then call it, and that should be fine. Okay, and we can define it way above, far away. All right, there is completely no consequence at all, like being very far away in the code from where we actually need it, and it is still okay, no issue at all. Square of 9 is 81. Okay, yeah, so that basically hopefully will clarify all the logic flow that Python understands, which you have to understand in order to drive this very powerful engine called Python. Oh, lastly, yes, right. When we define the function, right, the function is being defined. And if you call calc square, all right, we can call it and it will return a number. But if you call it in the wrong way, like this, without the bracket, the function itself, that means, hey, you know the code that is called calc square, that piece of code, that is also a value. The code itself is also a value. It's just like if you have a fan, right? This motor fan. If you run it, it will give out a lot of power in terms of the wind that it generates. Maybe that's what we want because it's very hot. We need the fan. But this fan motor itself is also a thing that can be sold. It's an item, right? It's an entity. So same thing, this function here, calc square, if you refer to it, it is a value. In fact, you can even say my function is calc square, right? You can assign that almost like saying my value is 3, you know, something like that. So be careful not to miss out the parenthesis, because when you didn't use that parenthesis, it is not a function call. It is talking about that function itself. You activate the function with a function call when you include the parenthesis itself, like this. Okay, just to emphasize that part again. And coming to this part of the discussion, the last part of our jump discussion is try and accept. Try and accept. Try and accept is really a very powerful mechanism in Python. Think of try, accept, pair. They come in pairs. Try and accept pairs, think of them as a supervisor. All right. So the way it goes is we put our code here, inside here, that we suspect may cause an error. What is an error? Such as 1 divided by 0. We know that in mathematics, this is an error. And if in mathematics it's an error, there's no way that Python will keep quiet about it. It shouldn't, because the right thing to do is to say it's an error. So we could purposely we could purposely produce an error, all right, or we can be innocent about it and say, okay, let's try, and see what happens. Yeah, okay. Suppose this is the case, and we run, and not quite unexpectedly, right? We do expect to see some sort of a strong reaction from Python, and basically, what this means is that we have a problem because the problem is called division by zero. It's an exception. It is like driving a car out of control. It careens to one side of the car, of the road, and we just lost control and it crashes. And this is not nice. For example, you don't want to let your users see this and start to have a frowned impression about how good your programming is, isn't it? Okay, but you might say, why would we ever do that? Yeah, we won't purposely program an error. That's true, because we might actually be doing this. Enter a number, right? We ask user to enter a number, and then we divide by the integer of the number. So convert that to integer. What we are thinking is that we would like to calculate the reciprocal of the number. All right, maybe because of some ratio, maybe because it's financial ratio or whatnot, we have to divide. So we will ask user, what is your number? We say 2, so 1 divided by 2, great, And if we ask about other numbers, those are fine. What if user forgetfully or rounding wise round down to 0? Then you will see a problem. Yeah, it's not so good, right? So it will be these areas that we actually want good protection over. So how to protect? How to protect? Now, most of the time, try and accept they're used to protect critical kind of codes that may fail beyond our best control. We cannot even check in advance. For example, when we try to open a file, and the file may be currently open for inspection by the user, then we are stuck. Right? Whether it's in Mac or in Windows or in other systems, it will be a file lock on the file, and you try to open for writing or reading, there may be issues because it's permission denied. Or you try to write into a directory, create a file when the directory was previously deleted by the user separately from your program, and then you will face a failure. Yeah, because you don't know in advance, you can't tell. So in those cases where it's unforeseeable and you suspect there can be a danger, that's when we use try and accept. For now, we'll illustrate try and accept using a trivial example, like 1 divided by 0. Okay, so since we now suspect that this part of the code may end up in error, we're going to protect it. That means we have a supervisor overseeing this part of the code. Okay. Only when there is no error will the code continue to sequence through towards the end of this block. However, whenever something's happened, for example, user enters 0, we calculate 1 divided by 0, this line will cause error. Then what happens is that with the try and accept, Python will monitor the execution. Whenever it is about to throw an exception like this, any exception like this, it will stop itself from doing that and jump the control over to the accept part, the starting point of the accept part. Let me say again. Suppose we suspect something might cause an exception in Python. It will end disastrously like this, right? And we want to avoid that. We want to capture that and process it our own nice way. What we can do is we insert the try in front. Begin protection, right? Begin monitoring. Monitor. If all goes well, user enters something that didn't cause error, then it will finish this block and ignore. And ignore completely the accept portion. Okay? So if everything completes well, the entire accept statement block will be ignored, as if nothing happened. But any part of this protected block, the supervised block, any part of it causes an error, such as 1 divided by 0, then immediately the whole and the rest of the statements will be ignored. Okay, so the input will be successful, but this will be problematic, and so on. And for the rest of the try block, nothing will be executed. Python will jump to the beginning of the except block and continue from there. Okay, so then we print the end. So what will happen? We will first see entering try portion. If we enter 2, right, 1 divided by 2, be 9. We'll see the word we found I equals to 0.5 and the end, because the except block is completely ignored. If, however, we enter 0 instead of 2, then we'll first see entering try portion. Enter a number, we enter 0, which is successful, the number becomes 0. But here, the attempt, not successfully, the attempt to divide 1 by 0 is going to cause error, will cause error. So it causes error, Python catches it because you did ask Python to catch it. It will stop and jump to the beginning of the except, prints, oops, an error, and then since that is done, it finishes the try and except block and continues and says the end, and then finishes. See that? All right, so the try except block makes our program very graceful because we cannot stop user from entering 0, but we have a nice way of saying, oops, I detected an error, or oops, please try again. We are unable to process 0. You can imagine I can change my messages there to provide a friendly advice to my user that he or she can try again, with non-zero value. Sounds intelligent, right? Sounds smart, right? Rather than exception, you can deal with it yourself. I don't know what happened. Even the programmer doesn't know what happened, isn't it? Yeah. So this is really useful. Okay. And with that, with the try and accept discussion, this really brings us to the end of all that you need to know about Python logic flow. So again, quick recap: sequence, condition, loop, and jump. So all these 4 types of flow allow us to mix and match, nest them. That means within sequence we have condition. Within condition we have loop. Loop, we also have a jump protection and calling function and so on. So we can do that and nest indefinitely many levels to express our real-world models. From that perspective, therefore, Python can do lots of wonders if you can successfully map the real-world logic and requirements to Python's 4 logic flow control blocks. Okay, good luck. I'll see you in the next video.